This is lesson CA9. This covers pages 72 to 80 in your textbook. In the description there will be a link to the textbook and the PDF version of lecture notes and a chart. The topic for today is factoring polynomials. In the previous lesson we learned how to multiply binomials. Since factoring is the opposite of multiplication, real quick let's just review this. We would have used the FOIL method to multiply everything in here, or the distributive method. 2x times x would give us 2x squared, and this would be negative 14x, and then positive 3x, and then the last two would be negative 21. Then we would have combined these two middle terms to get 2x minus 11x minus 21. Alright, I wanted to do that because a lot of times they call factoring polynomials unfoiling. Notice the relationship from where these numbers here came from. This number was obtained by multiplying the first two numbers in those binomials. This number was obtained by multiplying the last two. And this one we got here by multiplying the inner two and adding them. Okay, so notice that relationship because we're fixing to try to look at a trinomial and figure out what the two binomials were that it came from. Just the word factor. Factor can be a noun or it can be a verb. So we are going to do factoring and we are going to get factors when we do that. For example, if I take 12 and I factor it, that means I'm going to write it as something times something else. 1 times 12, 2 times 6, 3 times 4. That was the act of factoring, and what I got, all of these numbers are factors. When we factor polynomials, the very first step is going to be to take out any greatest common factor. That's always your first step. You won't always have one, but you always need to look for one. So what is a greatest common factor? Well, it's exactly what it says. Greatest means the largest, the biggest. The largest, what does it mean to be common? Well, everyone has it. If something's common, then everybody has that. So this is the largest number that all of the numbers have as a factor. So the largest number that goes into all of these. For example, 468. What is the largest number that goes into all three of these? It's just going to be 2. Now look at 3x, 6x, 18x. What's the largest number that goes into all of these? Well, 3 will go into all of them, but so will x. Let's look at this one. 5x to the third, 10x squared, 15x to the fifth. What's going to be our greatest common factor here? Well, as far as coefficients go, 5 will go into all of them. But now look at your variables. You've got x to the third, x to the second, x to the fifth. So we know we're going to have an x. And when you take your x, or when you look for a greatest common factor exponent, you want to use the smallest exponent there is. What is the smallest exponent of x that I have up here? It's going to be x to the second. Because remember, you want this number to be able to divide into all of these, but you want to get out as much as possible. Let's look at example 1, page 72. The directions tell you to factor out the greatest common factor. So we have this trinomial here. First, let's look at the number part, 6, 45, and 21. What's the largest number that will go into all three of those numbers? Well, you can start with 6. Will 6 go into all of these? No. So it's going to have to be less than 6. What's another factor of 6? Well, how about 2? 2 won't go into either one of those, but how about 3? 3 will. So that's how you find your common factors. Go to your smallest number and start going through those factors. The better you are with your multiplication facts, the easier this step is going to be. So my first is going to be 3. That will go into all three of these. Now let's look at the variable portions, because every letter that shows up in each one, that's going to be a common factor. So I have an x and a y. Now let's go back. I want to take the smallest exponent of each one of these things. Well, I have 3's, I have 2's, and I have 1's. So I'm going to stick with 1. Now this is your greatest common factor. What do you have left when you factor all this out? Well, when you factor 3y, and factor means divide it out. Factor into this, it's going to be 2x squared y squared. You want to be able to multiply this number times this number and get your original one back. So how many times does 3 go into 45? It's going to be 15xy. And then how many times does 3xy go into 21? Well, that's going to be 7. You don't need an xy, because when you multiply 3xy times 7, what do you get back? You get that 21xy back. Here's another example problem. We're going to factor out the greatest common factor. Now this looks a little bit different, but it is possible for a whole polynomial to be your greatest common factor. Your terms here are these two things. Remember, terms are separated by plus and minus signs. So when you look at these two terms, what do you see in common with both terms? Well, the x plus 1 that's inside that set of parentheses. Now if I divide it out of both of these, what do I have left? I have the 3 plus y. Now don't lose your greatest common factor, because that's a part. Remember, your finished answer should be equal to your starting expression. And if you lose things, if you lose factors along the way, then it's not going to be equal. So keep up with your factors. We're going to look at factoring 4 different types of polynomials. Now that sounds like a lot. And the first step is to analyze your polynomial. This is going to be easy though, because by analyze, all you have to do is count your terms. So when I count the terms on here, how many do I have? 1, 2, 3, 4. So we're going to have a method to factor a 4-term polynomial. Every polynomial that has 4 terms will be factored with the same method. All right, this one, count your terms, 1, 2, 3. However, count your terms over here and what do you get? 1, 2, 3. We have 2 different types of trinomials. The only difference is this one does not have a coefficient in front of your first term, and this one does. That's how you tell the difference on those. We call these polynomials where a, which is your leading coefficient, is equal to 1. We call these trinomials where a is greater than 1. So it's either equal to 1 or it's greater than 1. Alright, our last one down here is just got 2 terms. 1, 2. So we're going to have 4 different types of factoring. The main thing you have to do, or the first thing you're going to have to do, is count your terms. 2 to 4. Everybody can do that. So you count your terms and you have 2 terms. You only have 2 options. You can use the difference of 2 squares, or you can use the sum difference of cubes. So a lot of this is going to be analysis. How do you know if you need the difference of 2 squares? Well, you're going to use that formula that we looked at in the last section. Only last time we used it to multiply. Now we're going to use it backwards. So in order to use the formula, you must have a difference of 2 squares. You know your perfect squares, or you should. So you're looking for 2 of those numbers with a minus sign in the middle. If you don't meet those 3 criteria, you cannot use the difference of 2 squares. So let's just look at some examples. Analyzing. X squared is a perfect square. 25 is a perfect square. There is a minus sign in the middle. Look for a greatest common factor. There's not one. So we're ready to factor. You see how this resembles your formula. So if I have a squared here, later on in the formula where I see a, that represents the square root of a squared. So the square root of x squared is going to be x plus the square root of this. My next one is going to be x minus the square root of that. And that's all there is to factoring. If you want to check me, you can go back and use the FOIL method on this, and you will get x squared minus 25. So let's look at this one. 4x squared minus 81. Look for a greatest common factor. There is not one. So, is 4x squared a perfect square? Yes. Is 81 a perfect square? Yes. Is there a minus sign in the middle? Yes. So all I have to do is take the square root of the first plus the square root of the last and the square root of the first minus that. It doesn't matter if you put plus or minus first as long as you use one of each. Alright, let's look at this one. Is there a greatest common factor? No. Is this a perfect square? Yes. Is this a perfect square? Yes. Is this a minus sign? No. So, right now, this is just not possible because I have two perfects. I have a sum of two perfect squares. I can't factor that. Alright, just like, 7 is prime, sometimes polynomials are prime. Alright, let's look at this one. I have two terms, so I'm looking to see if I have a difference of two squares. Is this a perfect square? Is this a perfect square? No. But I haven't taken out the greatest common factor yet. Remember, that's always step one. I don't care what it looks like. Before you do any analysis, you take out the greatest common factor. Let's see what's going to happen to this when I take that greatest common factor out. The greatest common factor between 3 and 75 is 3. So that's going to leave me x squared minus 25. This is a difference of two squares. Now when you write your answer, don't lose that 3 because that 3 is a factor. So this is going to be 3 times x plus 5, x minus 5. Let's look at one more example of this type of factoring before we move on. 16x to the 4th minus 1. Look for greatest common factor, there's not one. It is a difference and it is two perfect squares. So anything that has an even exponent is a perfect square, and the square root of that is when you divide the exponent by 2. We talked about that in the last section. So let's just go ahead and apply the formula. This is going to factor into 4x squared plus 1, 4x squared minus 1. And this is what most people will put. I usually put this problem on almost every test that I've given for years on this section. And I very rarely have a very high percentage of people that get the correct answer because this is not the correct answer. It's fine as far as it goes, but you have not fully factored this polynomial. Because if you look at this, you still have a difference of two squares. Your factors can be factored. Now, this can't be factored because it's a sum, so I'm going to leave it 4x squared plus 1. But this, I'm going to factor it one more time using that same formula, and I'm going to get 2x plus 1, 2x minus 1. So, key takeaway, whenever you see an exponent larger than 2, and a 1, that might be able to be factored down even more. So this is going to be your final answer here. Okay, let's move on to the sum and difference of two cubes. This is the other method to factoring a two-term polynomial. And you're just going to have to look at, you still have two terms. Do you have squares or cubes? Look at your terms there. If you have squares, you're going to go with the difference of two squares. But if those two terms are perfect cubes, so what are your perfect cubes? Well, 8 is the cube of 2, and 3 times 3 is 9 times 3. 27 is a perfect cube, and going down the road. Now here's your two formulas, because you can do a sum or a difference of two cubes, and there's very little difference in the result. It's only the signs. And we have an acronym, SOAP, that helps you remember the signs. And this is same, opposite, always positive. So look up here at the formulas. If you start with a cubed plus b cubed, your sign is the same, it is opposite, it is always positive. If you have a cubed minus b cubed in your formula, you're going to have the same, the opposite, always positive. So let's look at an example. Let's take x cubed minus 8, and we need to factor it. So we've counted our terms. We have 1, 2. We've looked for a greatest common factor, and there's not one. We know that our options are a difference of two squares or a sum or difference of two cubes. Well, I see that this is a cube and this is a perfect cube, so that makes my decision for me. Once you've analyzed it and you've determined that it is a difference of two cubes, you're just going to apply the formula. Now we're going to be using the bottom. When you apply a formula, you have to understand formula language. If there is a cube or a power of a letter somewhere in a formula, and then later on you have just that letter, what that means is the root of it. So if this is a perfect cube, everywhere there's an A, that's going to be the root of it. Anywhere there's an A squared, that's going to be that root squared. So look at this. What is the root of x to the third? It's x. So we could make ourselves a little note up here that from now on, A is going to be x. And what is the root of 8? Well, it's 2 to the third power. So the root of it is 2. Now just to make it even easier, what is A squared? Well, if A is equal to x, A squared is x squared. All right, what is my B squared going to be? Well, it's going to be 2 squared, which is 4. Now you're just going to substitute in to the formula. So let's see. We've got A, which we just determined was x, minus B, which we determined is 2. Here we've got A squared. So that's the root of this squared, which we said is x squared, plus, all right, A times B, which is going to be x times 2. And then my last term is the B squared. So B is 2. 2 squared was the 4. And that is how you use the sum or difference of two cubes. I do feel like this kind of gets lost in the cracks somewhere between Algebra 1 and here. So if you're having difficulty applying this formula, would you drop me a comment down below, and I will make a separate video just about using this formula. But you might not have any trouble, but if you do, let me know and I'll get a video for you. Okay, so to recap so far, we're going to look at 4 different ways to factor. We just looked at how to factor binomials. Okay, now we're going to skip down here to polynomials with 4 terms. And we're going to use a method called factoring by grouping. And what does grouping mean? You use parentheses. So let these words guide you through your analysis. You're counting your terms, memorize 4 terms, factor by grouping. So what does grouping mean? Here's an example, 1, 2, 3, 4. There is no greatest common factor, so I'm going to group. How do you group? Well, evenly group the first 2 and the last 2. Now take out a greatest common factor from each pair of numbers. What's the greatest common factor between x to the third and x squared? Well, that's going to be the letter that's in both of them and the lowest exponent of x that you have, which is x squared. Now when I factor x squared out of this, remember you've got to be able to multiply these factors back and get your original. So what would I multiply x squared by to get x to the third back? You'd multiply it by x. Same sign. What would I multiply this x by right here to get x squared back? Well, that's going to be x plus 1. Now let's look at our next group. What is the greatest common factor between 4x and 4? Just the number 4. And if I want to multiply this back here and get my original, well, 4 times what will give you 4x? 4 times x. And then 4 times what will give you 4? 1. Now, look at this result. Do you see what happened? You now have another greatest common factor. So now we're going to pull this out. Pull out that set of parentheses from each one. It goes here. And then the numbers that are left here, the numbers that were on your outside, those, whatever sign that is, become your second factor. Okay? So this is factored form by grouping of this 4-term polynomial. Notice this is not a difference of 2 squares, it's a sum of 2 squares, and we don't have a formula for that. We have a formula for a sum of 2 cubes. All right, let's look at this one. Do I have a greatest common factor? Yes. 3 will go into all of these. Now, I don't have a y in this term, and I don't have an x in my last term, so I can't take out an x or a y, but I can factor out a 3. So let's see what we'll have left when we divide 3 out of each one of these terms. That's going to be 6x squared plus 4xy minus 3xy minus 2y squared. So now what I'm going to do is factor this. I'm not going to lose my 3. I'm just going to put it off over there. I'm through with it, but I don't want to forget it for my final answer. Now that you have this 4 term here with no greatest common factor, we're going to factor by grouping. So I'll just group the first 2 numbers and the last 2 numbers. Now within this set right here, within this binomial, what is its greatest common factor between 6x squared and 4xy? Well, let's see. 2 will go into both numbers. I have an x in both of them, and what's my lowest power of x? Just the x. And when I factor that out, I'm going to have 3x plus 2y left. Check yourself. If you multiply 2x times 3x, do you get this original number, 6x squared, back? Yes. If you multiply 2x times 2y, do you get 4xy? Yes. So that factorization holds. Now here, what do I have as a greatest common factor here? Nothing will go into 3 and 2, so I'm out of luck there. But, and I don't have an x in both of them, all I have is a y. So let's pull the y out, and when I divide y out of this, I'm going to get 3x. Now here's where you have to be careful. This one is different because this number is negative. So when you pull that negative out, it reverses the sign in here. So this is going to become a plus sign. Now when I take y out of 2y squared, I get 2y. And once again, if you look, these 2 things match. When you are factoring by grouping, at this point, these 2 sets of parentheses have to match, or you did something wrong. It's not the problem. You did something wrong. You didn't pull out the greatest common factor. You forgot to change your sign. Something. You go back and find your mistake, because these 2 sets of parentheses have to match at this point. So now I'm going to pull, I'm not going to lose my 3. These 2 sets of parentheses, I'm going to pull this out of each one, so I just have it once. And my last set of parentheses is going to contain this number and this one. So I've got 2x minus y. And I promise you, if you go back through and you multiply all 3 of these terms together, you will get this original expression. Well, that just took care of your 4-term polynomials. Now all that's left are the 2 trinomials. So let's look at these. How do you tell the difference? First of all, it's a is equal to 1 versus a is greater than 1. And you know, a in a polynomial or a quadratic refers to the leading term. Your standard form is ax squared plus bx plus c. So that's why we say a. It's the number in front of that x squared term. If it's 1, you're just going to see x squared. But if it's greater than 1, there's going to be a number there. So first, we're going to look at the kind that have just a 1 or nothing there. This is your easy one. Thinking backwards, you know that this trinomial was obtained by multiplying 2 binomials together. So let's unfold it. What did you multiply together to get x squared? The first term in each binomial is going to be x. So now let's think about the signs that go in here. I have a little chart. If your trinomial has a plus and a plus, then your binomials will have a plus and a plus. If your trinomial has a minus here, but a plus in the second position, then you're going to have two minuses. So in other words, if your second sign is a plus sign, your signs are going to be the same, and they're going to be whatever this is. Now, if your second sign is a minus sign, you're going to have one of each sign in here, and it doesn't matter which sign goes where. That will sort itself out later. But anyway, so you might want to remember this chart. Alright, so we've got x and x. Since this is a minus sign, look over here, I'm going to have one of each sign. So I'm just going to put a plus and a minus. Now I need to figure out what number goes in these two positions. And remember, there's two characteristics of these numbers. I have to be able, according to FOIL, when you unfoil, I have to be able to multiply them together to get negative 10 and add them together to get negative 3. And I'm sure in your head you've already picked those two numbers up, but let me show you the process in case you have a problem where you can't figure that out. You're going to look for all the factors of 10, negative 10. So that's going to be negative 1, positive 10, positive 1, negative 10. And you can stop as soon as you find a pair that adds up or combines to give you negative 3. So it's going to be negative 2, positive 5, positive 2, negative 5, and look at there. This pair adds to give us 3. So that's going to be my other set of numbers. Now where do they go? Well, since 2 is positive, it's going to go where the plus sign is, and 5 will go here. If you want to check it, FOIL it real quick. X times x is x squared. This is 5x, negative 5x plus 2x. That gives you negative 3. And then positive 2 plus negative 5 gives you negative 10. Example 2, page 73, factor this trinomial. I see that my coefficient here is 1 because there's not a number here. I see that this is a minus sign. I look for a greatest common factor and there's not one, so I'm ready to factor it. Now I know that this trinomial was achieved or was obtained by multiplying two binomials together. And since this is an a equals 1, I know my first terms in each one of these binomials is going to be x. Now what sign? This is a minus sign. If your second sign is a minus sign, you're going to have one of each, and it doesn't matter where they go. Then I'm going to look for all the factors of 15, keeping an eye out for the pair that will combine to give me this middle number, which is 2. So I've got negative 1, positive 15, positive 1, negative 15. Now there's one thing. If this is a plus sign, you're not going to have alternate pairs. You would just have 1 and 15, 3 and 5. You know, if it's positive, both are going to have the same sign. So let's see, negative 3, positive 5, positive 3, negative 5. And I'm looking for positive 2, so there's my pair. Now where do the numbers go? Well, since the 3 is negative, it's going to go here, and 5 is going to go here. Now one note, what if you don't have a pair of numbers that adds up to give you this middle term? Can't factor that, okay? You're just done, put prime. So if you don't have a pair that adds, and that's why you have to be careful making your chart. I go in order. I don't just jump around. Go in order. That way you'll know if you haven't missed anything, because you don't want to miss the pair that you need. So go in order, be organized, and if you don't have a pair that adds up to give you the middle term, it's just prime. And we're on the last method now. This is for a trinomial that does have a coefficient in front of the first term. A lot of people, including me, call this the AC method. Your book calls it factoring by grouping. I know that the method we used for 4 terms, we called that factoring by grouping, but here in just a second you're going to see why these can be called the same thing. Now, when you call it the AC method, AC means multiply A times C. Well, you don't see an A and a C in your problem, but our format for standard form of a quadratic looks like this. AX plus BX, AX squared plus BX plus C. I know you've seen that. So the coefficient of your x squared term is A, and your last term is C. So that's where those two numbers come from. We're going to take A and we're going to take C and we're going to multiply them together. What's 15 times 2? That's 30. So this is going to be quite similar to the method we just used for just a second. When I multiply these, I'm going to get the factors of 30 and I'm looking for the pair that add up to give me this middle term. So I've got 1 times 30, I've got 2 times 15, 3 times 10, and I can stop right there. Now in the other method, you took those two numbers and put them in your binomials. Well, we're not going to do that here. This one doesn't work this way. This is where it veers off and becomes factoring by grouping. How many terms do you need to factor by grouping? You need 4. So what we're going to do is we're going to transpose this trinomial. We're going to make it a 4-term polynomial by changing that middle term. We're going to leave the first term just like it is. We're going to take these two factors that we found over here and we're going to rewrite this middle term as 3, whatever letters are there, plus 10xy plus 2y squared. Now you see, that's still the same. I have not changed the value of this expression, I just changed its appearance. Now that I have a 4-term polynomial, I'm ready to factor by grouping. So in reality, all you're doing here for this method, for these trinomials, is you are converting that trinomial into a 4-term polynomial so that you can factor it by grouping. So now, what's the greatest common factor between these two things? Well, 3 and x will go into both of them. So when you factor that out, 3x times what would give you the 15x squared back? 5x. And 3x times what would give you 3xy? Plus y. All right, down here, what's my greatest common factor? 2y. Now when I divide it out of here, I get 5x. When I take it out of here, I lost a square. That's going to be y left over. Now, look at your sets of parentheses. Remember I told you, if they don't match, you messed up. That's actually what caught my eye. That's how I knew I lost my square exponent from the original here, because it wasn't going to work out. All right, now, your first set of parentheses becomes that 5x plus y. Your second set of parentheses is made up of these two numbers, 3x plus 2y. As always, check these to see if you can factor it anymore. You might have a difference of 2 squares, but not usually. If you want to check your problem, use your full method. Remember guys, this is a prerequisite chapter. So this is stuff, this should just be a refresher for you. If you're still having difficulty, we are trying to build speed. We're trying to gain confidence so you're not stumbling through these problems. And we're trying to find gaps and fill them in. So if you found a gap right now, you let me know and I will help you fill it in.